Alright, welcome back. So we're on page 13, and I know that at this point you have been itching to, when given a subtraction problem, to actually change it to taking away, to placing the negative. So for example, if we were given 2 and you had to take away -3, you would say, so 2 minus a -3, you would say we don't have a -3 to take away, so I'm just going to add a +3 instead. Now, that is not subtraction. That is adding the opposite. So this is not something that we can model, that if we were modeling it that way, would not be modeling through subtraction. So what we need to remember is that addition is placing, and subtraction is removing. If you're not removing during subtraction, then you're not modeling subtraction. So if we were to model the 2 minus a -3 here, then we would have to say, well, I am going to add 3 0 pairs. I'm going to place 3 0 pairs so that I can remove -3. So that would be 5. So does that make sense? So what we did was we actually placed the 0 pairs and then we removed the -3. Now, if we were modeling adding an opposite, which is 2 plus 3, we would simply be adding 3 on the right side. And it does seem simpler, and it does give us the same answer. So those are equivalent, but we need to figure out why those are actually equivalent. So let's do this thing on the left again, the process on the left, the subtraction. And I'm going to switch colors. So what we're doing, if you look at step 1, is placing the left, the 3 units on the left and the 3 units on the right. And step 2 is taking the ones on the left and removing them. So if we just focus on what we did on the left, in step 1 we placed them, in step 2 we removed them. What did we do on the right? In step 1 we placed them, in step 2 we didn't do anything. So if we needed to summarize what was happening on the left, in step 1 we placed 3, in step 2 we removed them on the left hand side. What is actually happening here? Well, you place them and then you remove them right away. So what's actually happening is overall nothing happens on the left. Whatever you do, you undo. And that's why this nothing happening on the left here is actually equivalent to putting something and removing it, putting it on and removing it, right? So that's why we can say that it's the same as not doing anything on the left-hand side, but just placing the right-hand side pieces on the right. Okay, let's try again and see if we can find the same kind of pattern happening in the second problem. So we have -3, -3, and we need to subtract 5. Now we don't have 5 to subtract, so we need to place 0 pairs. And then what we need to do is subtract the positive. So what we did on the left was we placed the 5. What we did on the right was we placed the 5. That's the first step. The second step, we didn't do anything on the left, leaving those 5 there, but on the right we removed them. So overall on the right, we placed them and then we removed them. So it's actually overall on the right, in the grand scheme of things, we didn't do anything. So that's the same as not doing anything on the right, but simply putting them on the left. So that's why subtracting is the same as adding the opposite. You can always remodel subtraction as adding the opposite. Those two things are the same. The thing is that we need to remember is that we cannot use that as a trick until the students understand what subtraction is and why it is the same as adding the opposite. So at any point in time, students must be able to explain why, if they're modeling subtraction as adding the opposite, why those two things are the same.